Hello, everyone. If you are studying IGCSE Computer Science 0478 Paper 1, this video series will help you revise each topic more easily. We'll go through chapters 1 to 6, practice questions like those from the past papers. This will help you understand the types of questions you will see in the exam and how to answer them. These videos are designed to support your learning, build your confidence, and help you to get best grades you can. So let's get started and make your revision count. Topic 1, binary numbers. Okay, question 1. State what is meant by the number system. Give one example of a number system used in computer science. So a number system is a way of representing numbers. The number system used in computer science is known as binary number system. Question number 3, state two characteristics of the binary number system. Here you can see the first one is it only uses 2 digits. It has a base of 2. Each digit represents power of 2. It is used by computers to represent the data. It is easily implemented using the electronic circuits. Question 4, explain why computers use binary number system. Answer. A computer is an electronic device. All electronic devices are made of transistors. Each transistor has 2 states, on and off. These 2 states can be represented using 1 and 0. So that is why computers use binary number system. Next topic is Denary to binary. Okay. A small business owner, David, is creating a simple encryption program to protect customers' data. He needs to convert the ASCII Denary value of the letter N, which is 78, into the binary representation for a specific part of the encryption algorithm. Give the binary number for the ASCII Denary number 78. So we need to convert the Denary number 78 to binary. So how do we convert it? So we just need to divide the number by 2. Okay, so 78 divided by 2 will get 39. 39 divided by 2 will get 19, and just go till we get 1. Next is to add the carries. Okay, so if the number is odd, the carry is 1. If the number is even, the carry is 0. So now let's add the carry. So 78 is a even number. That's why the carry is 0. 39 is an odd number. That's why the carry is 1. 19 is 1. 9 is 1. 4 and 2 are even. That's why the carry is 0. So now we got the carries. Now we just need to write those carries. So how do we write the carries? We write from top to bottom. So starting from here and here. So our answer will be what? Our answer will be this one. So why we have an extra 0? Because we need to give the answer in as an 8-bit binary number. So that's why these are 7 bits. So that's why we need to add 1 0 here to make it 8-bit number. Okay, so as you can see here, starting from here, 1 0 0, 1 0 0, 1 1 1 and 0. Okay, question number 7, an alarm has been set for 7:30. Two 8-bit registers C and D are used to represent the hours and the minute of the alarm time. So how 7:30 would be represented by these 2 registers? So first of all, we need to convert 7 to binary, and then we need to convert 30 to binary. Okay, so let's convert the 7 to binary. So this is the binary of 7, is which 1 1 1. Then next one is what? Is 30. Convert 30 to binary. So remember, it's an 8-bit register, so we need to have add the zeros before those ones. Okay, so you can see this is the register C. So we have this number 1 1 1 here, and rest of them we'll fill it with the 0. Same thing goes for the 30. We fill it with this the number for the 30, binary number for the 30, and rest of the bits we fill with the 0. So our answer is what? C and D. Here you can see the answer. Now let's see Denary to hexadecimal. Okay. So convert the Denary number 212 into hexadecimal equivalent. Show you are working. So now we have a Denary number 212, and we need to convert it to the hexadecimal. So before converting the numbers to hexadecimal, you need to remember this table. Okay, so you can see here, these are the Denary values, and these are the hexadecimal values. So you can see from 0 to 9, the values are same. Hexadecimal and Denary values are same. But in hexadecimal, there is no 10. We represent 10 as A, and 11 as B, 12 as C, 13 as D, 14 as D, and 15 as F. Okay, just remember this one. So now we first need to convert 212 to binary. So where is the binary of 212? Here you can see this is the binary of 212. Next, we need to write the bits. So these are the bits. Okay, and next step is what? Next, we need to divide the bits into group of 4 bits, because each hexadecimal number is represented using the 4 bits. So first 4 bits, these are so 1 0 1 1, and next 4 bits are what? 0 1 0 0. Now we just need to add those numbers together. So 8 plus 4 plus 1 is what? Is 13, and 4, this is only 4, so we just write the 4. So now we need to see 13. What is 13 in the hexadecimal? So 13 in hexadecimal is D, and what is 4? 4 is 4. So our answer is what? Our answer is D4. Okay, question number 10. Hexadecimal can be used to represent binary numbers. Convert the Denary number 236 into hexadecimal. We have a table here. And now we need to convert this one to binary first. So here is a binary of 236. Okay. And then same thing. We need to add the number. Okay, this is our binary number. We need to split it into the group of 4 bits. And then we add the numbers together. So 8 plus 2 plus 4 is what? Is 14. And then you have 12 here. So what is the hexadecimal symbol for 14? It is E. And 12 is what? C. So our answer is what? E, C. Okay, next topic is binary to Denary. Okay, so question number 12. Following binary numbers is stored in an 8-bit register. This is the number. Convert the binary number to its Denary decimal equivalent and show all of your working. So how do we convert a binary number to decimal? It's very straightforward. We just need to write the power of 2 and write the number underneath them. And then we just add the numbers where we see the 1. For example, 64, 32 plus 8 plus 2 plus 1. So we add all those numbers and we got the number 107. So our answer is what? 107. So this binary number is equal to 107 in what? In Denary. Okay. Next one, an alarm clock is controlled by a microprocessor. It is used 24 hours clock, and the hours are represented by an 8-bit register A, and the number of minutes is represented by another 8-bit register B. So we have two registers A and B, and this for the first register shows the number of hours, and the second register shows the minute. Identify what time is represented by the following 8-bit register. So simply we add those numbers underneath and we find the 1. So 16 plus 2 is what? 18. Okay. And this one is what? 32 plus 16 plus 4 plus 1, we got 53. So time is what? 1853 shown in the clock. Okay. Next topic is binary to hexadecimal conversion. So now let's see how we can convert a binary number to hexadecimal. So the following 8-bit binary number is stored in the memory. So this is the number. Convert the binary number into the hexadecimal equivalent and show all of your workings. Similarly, we need to know this table. Okay, you already know this one. Next step is we split the number into group of 4s because each hexadecimal number can be represented using a 4 bits, right? So next we convert this number to what? To Denary. So what is the Denary of this number? It is 8 plus 4 plus 1, which is 13. And now this number, so which is what? 4 plus 2 is 6. So what is the hexadecimal symbol used for 13, which is this D, and 6 is as 6. Okay, so the answer is what? D6. Now question 16, the binary number stored for an address, and this is the long number binary number. Convert the binary number to hexadecimal. So same thing, we need to split the number into group of 4 bits, 4, 4, 4. And then we just convert those numbers in separately to Denary. So the first one is 1, second one is 9, and the third one is 11. So what is the hexadecimal of 1? 1 is equal to 1, and 9 is equal to 9, while 11 is equal to B. So our answer is what? 19B. So this binary number is equal to 19B in hexadecimal. Now let's see hexadecimals to binary. So now if we have a hexadecimal number, how do you convert the hexadecimal number to binary number? So convert the hexadecimal number 3F to its binary equivalent, show all of your workings. So same thing, we know that each hexadecimal number is equal to 4 bits. So first we convert 3 to binary. So what is the binary of 3? So 2 plus 1 is 3. So this is the binary. What is the binary of F? F is what? 8 plus 4 plus 2 plus 1 is equal to 15 because it's 15. So that's why our binary number will be this one. 00111111. Okay. Next question, convert the hexadecimal number A to F to its equivalent binary representation. So first we convert A. A is what? A is 10. So where's the binary of 10? It's 1010. Next number is 2. Where's the binary of 2? It's 0010. Next one is F. F is what? Is all 1. 1111. So our answer is what? This number. So 1010, 0010, 1111. Okay. And topic number 2 is hexadecimal numbers. So now let's see some questions related to the hexadecimal numbers. State the 2 key characteristics of hexadecimal number system. So we need to tell the characteristic of hexadecimal number system. Okay. So first one is it uses 16 digits. Digits are 0 to 9 and A to F. It's a base 16 number system, and 1 digit is equal to 4 binary digits. Identify 2 ways hexadecimal is used in computer science. So here are some ways the hexadecimal is used. Number 1, it is used in HTML colored codes. It is used in URLs. It's used in memory dumps. It's used in IP addresses, especially IPv6. Okay. It's used in MAC addresses. Assembly language uses hexadecimal number system. Error codes or error messages also use the hexadecimal number system, and it's also used to represent the ASCII and the Unicode characters. Okay. Question 23. A programmer is debugging assembly code for microcontroller. Give one way that hexadecimal is used in this low-level programming context. So here we can see it's used in assembly language, it's used in the memory address location, in error messages, in memory dumps. Okay. Next one is give one benefit of using hexadecimal instead of binary to represent the data. So here are a few. So hexadecimal is more compact representation of binary values. Yeah, it's easier for humans to read than a long binary string. It's easier for humans to write than long binary strings. There is less chances of errors when writing or reading the hexadecimal values compared to the binary values. It's easy to convert between the hexadecimals and the binary representation.